And it is that anticipated moment, Friday, at about 9:35, we connect with the Naked Scientist. Dr. Chris Smith is a consultant virologist at Addenbrooke's Hospital in Cambridge, and he joins us live. And the opportunity, of course, to have your question, that one that keeps you up at night, answered, that is available to you. You can send those questions through via WhatsApp at 072 567 1567. Or you can call us on 021 446 0567 and we'll prioritize your call. Welcome, Chris. Great to have you back.
Yeah, good to talk to you, Clarence. Good morning.
Okay, we're going to dive straight in. And the first question in this morning, just after 9 o'clock, can you please ask Dr. Smith to explain consciousness from a scientific perspective?
You can certainly ask me, but can I answer the question? Absolutely not. There many famous neuroscientists have died on the hill of consciousness. And I think one of them even went as far as to say that consciousness is the graveyard of many a good neuroscientist, because it's just not tractable to the way that we tend to think and study about and think about the brain. We became very good from about 100 years ago. There were some really fantastic neuroanatomists who came along because they had the tools and they had the inclination to try to understand the brain. And they documented in painstaking, excruciating detail all the different cell types, where they are, how they make these amazing connections to each other. And they drew beautiful pictures which stand the test of time. They were absolutely right, even with the more primitive techniques they had 100 plus years ago, these researchers. We've understood much more about the electrophysiological basis of the brain, how nerve cells move charged particles across their membranes in order to create voltages, which can then enable them to send electrical signals down these thin conduits from one cell to another. But what we can't understand is when you bring all of that together, how it creates the experience that we call consciousness. When I look at the world and I look at you on a screen or whatever, I see you in front of me. That's where my eyes are, of course. But you're not there in my brain. You're actually at the back of my brain. And my brain is creating the picture of the world I'm looking at in enormous numbers of nerve cells at the back of my head. But why do I experience you in front of me then? And does the colour that I see match up with the colour that you see? Or is it just because I told you that's a blue wall and you said, oh yes, I experienced that experience and call it blue? We don't know. So we have no way really of understanding what consciousness is, how these populations of nerve cells, by working together, wiring together, firing together, create the experience that we call consciousness. And therefore, what size brain you need in order to be conscious. Is my dog conscious? I think it probably is, based on the way that the dogs behave. But do I get to a mouse and say, well, that's conscious? Perhaps it is. It has a very similar brain structure to a human in many respects. There are all the same bits of the brain there. They're just smaller with different numbers of nerve cells in them. Is that conscious? Where do you go? Do you get to a point where a caterpillar is conscious? We just don't know, and it's a very hard question to answer. So it has defeated and continues to defeat the best minds in neuroscience, but we are pushing back the boundaries, and what we do know is a lot more about how individual bits of the brain do what they do, how they talk to each other and send messages around the brain, but how we bring all that together to create the experience that we call consciousness. I can't help you, I'm sorry.
Yeah, I thought that was an interesting question. Thank you very much. Let's go to Christine's question. Good morning, Dr. Chris. Can you please explain the Nipah virus? Is it safe to travel to a place like Bali at present?
Nipah first surfaced in humans in the late 90s. It was 1998. And Malaysia suddenly detected a huge number of cases of humans with this new encephalitis, swelling of the brain that we hadn't seen before. Some cases also cropped up in neighbouring Singapore. What connected all of the initial cases was they were all farmers who kept pigs. So people immediately assumed this is a pig virus and they went after pigs, because normally when you have an outbreak, if it's an animal origin, which the majority of new and emerging infections, more than 75-80% of the time are, you cull the source animal and you should rein it in. And so they killed 1 million pigs and the outbreak stopped. But what was happening is that these pigs were giving an infection to the farmers who, unlike the pigs who had a respiratory infection with Nipah, the farmers were getting a brain infection and half of the time dying of encephalitis. Where did it come from? Well, the pigs aren't actually the source, as it turns out. When they unpick this, it is a bat virus. And in that part of Malaysia at that time, they had built enormous numbers of piggeries in the virgin rainforest, and the piggeries were right next door to orchards. So what was happening, you can probably see this flying in towards you in terms of comprehension, that the fruit orchards attracted fruit bats, which picked the fruit, ate the fruit, and dropped the droppings and their saliva on some of the fruit into the pig pens, where the pigs picked up the half-eaten fruit covered in bat excrement, urine, saliva, and Nipah virus, which was in the bats. The pigs caught Nipah virus. The pigs had a respiratory infection with it, and that then got it into people. So that's how we discovered it. Once they had the signature for the virus, people began looking around the world and found that, in fact, this was not a one-off in Malaysia. It was happening in other parts of Asia as well. Bangladesh was having cases. India recently have started to have large numbers of cases. So in the intervening 30 years, we've seen many outbreaks with this. Bats remain the common origin, and it's where bats and bat body fluids get into contact with humans, sometimes via an intermediate like a pig, but sometimes directly, often through things harvested from trees, like date palm juice, for example. The bats will come along and contaminate samples which are being collected by humans, and the people then pick it up. Once you've got a person with Nipah virus, they can then pass the Nipah virus on to other people. So then you get a human outbreak. So the key thing is this is out there. It's a zoonosis. It's in nature. It's in an animal reservoir. This is not just a human infection. And therefore, in order to make a risk assessment, what you have to do is to ask, well, where is it circulating? We know that it's in the bats, but are there any areas which are seeing outbreaks? There are also often seasons with these things. So you look at what the seasonal pattern is. So you look at the geography, the seasonal pattern, and then you ask, well, what am I going to do when I go to these places? The highest risk places are where you might come into contact with the animals that carry this, or where there's a high likelihood of you spending a lot of time in contact with people who might have done the aforementioned. The numbers internationally remain very, very low in the grand scheme of things. This is not COVID Mark II at the moment. It's small numbers of people in clusters, but it's certainly a nasty virus, and it's not one I would like to catch.
Sally, you've jumped the queue. Welcome. It's good to have you.
I just want to ask Chris, how do I save my lawn from my dog peeing on it? It keeps going brown, and no matter what I do, I can't win.
I'm in the same position, Sally, because I've got two dogs, the older one, and he's the dad of the newer one, and puppies tend to be quite habitual, so she would always go out and pee in the same place every day, and I started to get big brown patches. The reason the pee kills the grass is because pee is very salty, and especially in dry weather, the urine goes on the grass. It's a big salt burden, and this obviously plants don't like salty soil. It's why you have to have certain plants grown by the seaside, because other things can't tolerate the salinity. So there are two options here. Number one, rip up the grass, lazy lawn. That's the simple one. The other option is get the dog to pee in random places or somewhere else, or you've got to be really diligent about watering the patch of grass to dilute out the salt, which when we're all trying to do better water stewardship, that's not great either, especially when water becomes pricey. So really, that's the reason. It's not that there's anything poisonous in the urine, it's the salt in the urine, and the plants don't like it.
Keith, by the way, Sally jumped the queue because she called 021 446 0567. If you call, you'll jump the queue. But we're going to go to the third question in this morning. Of course, we're interacting with the Naked Scientist, consultant virologist at Addenbrooke's Hospital, Cambridge, Dr. Chris Smith, and your questions on 072 567 1567. That's a WhatsApp number. Keith says, Chris Smith, morning. What is an induced coma? Is it a safe option?
Hello, Keith. Well, a coma is a state of unconsciousness. This is something actually we're in when we go to sleep at night. We're in a controlled unconscious state because the brain changes the way that those populations of nerve cells are talking to each other, and this puts us into a state where we are insensible and unaware of what's going on around us until we reawaken. We can also induce a coma chemically. And there are certain drugs, general anesthetics, in other words, which through various mechanisms get into the central nervous system, the brain, and they either dial down the level of excitation or they dial up the level of inhibition, because the brain is a push-pull series of inhibitory and excitatory signals. And by manipulating either or both, you can change the overall level of brain activity. So if you dial up the inhibition, then brain activity drops, and it drops below a threshold at which we need the brain to be firing for us to be awake and aware. Neuroscientists talk about particularly impacting on what's called the reticular formation. In the brain stem, which connects the spinal cord to the top part of the brain proper, there are various collections and assemblages of nerve cells there, which form important networks of cells that ramify or run through the nervous system and use various chemicals to unify the firing activity across the brain and increase its overall activity. And we know that if you damage this reticular formation, you can affect consciousness. They include various transmitter chemicals, including histamine even, which is why antihistamines, if they get into the brain, if they're the ones that don't only stay outside the brain, they make you feel very sleepy. So they dial down this reticular formation. So when we induce a coma, we are dialing down excitation in the brain, dialing up inhibition in the brain, and overall reducing the activity of your reticular activating system, which is what makes you wake up when you wake up and go to sleep when it switches off.
Dave, you've jumped the queue and you're welcome.
Good morning, Dr. Chris. I'd just like to ask you a question in connection with pain and pain thresholds. Is there an official scale that people work to? I mean, some people have got different pain thresholds to others. How does it work? Do you know?
Yeah, it's very difficult because pain is a subjective thing. You sort of hit the nail and possibly your thumb with a hammer on the head. Because what is one person's pain is actually another person's pleasure, as we all know if you've read some saucy books and that kind of thing. I'm being slightly facetious, but there are differences from one individual to the next. Some people will say, yeah, that was a bit of a scratch. Other people will scream blue murder. I've had patients in the hospital where you can dig around to try and get a needle into them to put a venous cannula in, and they just tell you to get on with it, whereas other people, you haven't even got the needle anywhere near them yet and they're already screaming. So it's very subjective, but the reality is that pain is real for that person, regardless of how much pain you give them. When scientists were studying the placebo effect, they wanted to get some way round this, and one way to do it is to use various visual scales. So you've got a 1 to 10 scale of pain, and you can apply a stimulus which you can adjust for one person to the next, so that you end up with people all saying that's about 5 out of 10 on my pain scale. So when we do this sort of research, you tend to use that approach where you do it relative for the person. So you establish their baseline, and then you're comparing apples with apples to an extent. But apart from having those sorts of visual readouts and a sort of 1 out of 10 to 10 out of 10 pain scale for a person, there's no equivalent to the Richter scale, as it were, for pain, like there is for earthquakes.
Interesting that you're talking about placebo. Denzel has a question about placebo effect. He writes, if a patient knows they are taking a placebo, but it still works, what does that tell us about the brain's ability to self-medicate? Can we think ourselves into health?
Yeah, you can. You can think yourself into health. You can think yourself into ill health as well. And I think I spoke on this program previously. There's a lady I talked to before Christmas in Germany, did this really interesting study on what we dub the nocebo effect. Because the placebo effect, the word comes from the Latin placebo, I will please, which is if you give someone something telling them this is going to have this effect on your body, even when they know that it's a placebo, it still has a therapeutic effect on the body. You can do the mirror image. You can say to somebody, if you take this pill, it will produce the following side effects. And she's actually done some measurements on that and found that indeed this works exactly the same way, like the mirror image of the placebo. And you commonly see this in medicine. People will say statins, the drugs that lower cholesterol, cause muscle aches and pains. And when you ask patients, have you had any side effects? They'll say, oh, terrible aches and pains when I took these drugs. In fact, when they did studies showing that if you give people dummy pills or statins, you get exactly the same rate of muscle aches and pains in both groups. So, in fact, it's people thinking they need to have the side effect that causes the side effect. So you can get actually both effects. But what the lady in Germany showed is that, in fact, the effect is more pronounced for the negative effects than it is for the positive ones. So not only do we know that this happens, we also bias it in favour of negative outcomes. To her mind, this is because we are taking a better to be safe than sorry cognitive approach to this sort of thing. I'd rather come off worse. So it can work in both directions. So be careful what you wish for. But yes, you certainly can think yourself towards a state of feeling happier, feeling healthier, and feeling like you're in less discomfort.
Because I'm happy. Poloso, you've jumped the queue, and you welcome.
In terms of the state of matter, we know that there's 3 states, but there's a 4th one, which is plasma currently. Once water gets to that state, can it be reversible? Can it go to any other state after comes a plasma?
Okay, what Peloso, and good morning, Peloso, what Peloso's saying is if we look at the atoms around us, they can be organised into a solid. So if you have, for instance, a metal, that's lots of metal atoms stuck together. If you heat those metal atoms up, they can become molten, they become a liquid, and you can pour the metal to cast it. If you kept on adding energy, you could split them into a gas, possibly. You can have gaseous particles. If you kept on adding energy after that, you can actually rip the particles apart, and this is the 4th state of matter, into a plasma. And this is where you've got so much energy that the positive bit in the middle of the atom has been ripped away from the negative bit, the electrons around the outside, and they exist in a kind of soup. But they don't have to stay like that. They will recombine. So all these things can be switched between. You can make a plasma in your microwave if you want to. A nice demo that we wrote up in our book, Crisp Packet Fireworks, that you can do. You can do this in a range of ways. We did it with a scouring pad, where if you put a scouring pad in the microwave, don't do this at home, please, but if you do this in your microwave oven, your wife will kill you if you damage it, which is why I'm saying don't do this at home. You induce a big current in your metal scouring pad, which heats up the metal, which in turn heats up the soap, which is in the scouring pad, and gives it enough energy to break the soap particles apart into a plasma, and you get these balls of glowing plasma which go off of the scouring pad up towards the top of the microwave. Other people have done it by putting a grape in a microwave and splitting the grape into 2 halves connected by a thin bit of skin, and you can sometimes get that to make a plasma as well. But it's certainly a reversible process. You make a plasma and then you recombine all the bits of the atoms back together again as the energy falls.
Okay, Vanessa's on the line as well. Welcome, Vanessa. Great to have you.
Good morning to Dr. Smith. I am asking for a friend. She has been diagnosed with an eye condition. And when you were speaking about thinking yourself well and thinking yourself sick, she's losing her sight. And people are telling her that she must stop giving attention to this vision loss. She must think herself better. And the specialists told her that it is the lens in the back of the eye that has hardened and became opaque, and therefore she's losing her vision. But now people are trying to tell her that she must think herself better. So I'm just wondering, do you think one can think your eye better when it's already deteriorated?
Sounds like she might have some kind of cataract, Vanessa, but the answer to this is that symptomatically we can control our experience of disease by the power of thought. That's the placebo or the nocebo effects I was mentioning. So if I know something's going to hurt, I can make it hurt less if I think about it in a certain way, or I take steps to take tablets, placebos even, which will give me a psychological ability to wrestle with those symptoms. But what we can't do is to control a pathological process with the power of thought. We can influence it. And by that, I mean that I was talking to some people last week who were doing studies on how the way we feel affects the manifestations of the immune system, for example. there are lots of studies showing that if you're stressed, you will make a much less good immune response to a vaccine than if you're not stressed. So you can certainly influence symptoms and you can influence rates of certain pathologies, but you can't think yourself better just because you're thinking about it, because the mechanism of a pathology, if you take a cataract, it sounds like with a fogged lens, it sounds like that might be a cataract leading to some visual loss, and it's thankfully reversible if that's the cause, because you can replace the lens. But just because you're thinking about fixing a lens which is fogged, you can't reverse the chemical changes that have happened to the lens, but you can certainly think along the right lines to make the symptoms less high impact for you, so that you can change your life in a way that means you can adapt to whatever the challenge is that's confronting you, but you can't necessarily reverse it. So that's what I was getting at, and that's the subtlety or the nuance of the placebo effect affects our ability to experience things and how they impact upon us. It doesn't actually affect the disease process itself.
We're going to wrap it there. Time approaching 3 minutes to 10 o'clock. A big thank you to the Naked Scientist. Of course, you can get him. Just give us that website address. Is it nakedscientist.com?
Yes. So what we do after this program finishes, each week we will take the audio from, or we do take the audio from this program, and we clean it up a little bit to make it as tight as possible. And then we put it as a podcast, and you go to nakedscientist.com/ask, ASK, because that's where we corral together just these phone-ins with you and me. And you can get that at nakedscientist.com/ask, or you go onto where you get podcasts and you just look up Ask the Naked Scientist.
Somebody reported that they did an AI search for you and it came up with The Naked Scientist, and it was a completely different domain.
Yep.
So don't put the in front of it.
No, thenakedscientist.com is us. You can use that, but if you look up Ask the Naked Scientist on a podcasting platform, you will get this program as a podcast.